Hi, in this video I'm going to show you how to balance chemical equations, but before I do that, I need you to know some terminology. First of all, when we look at this chemical equation, anything that we see on the left-hand side of this arrow is a reactant, and anything on the right-hand side of the arrow is a product. You can see that I filled in the word left and the word right here for reactants and products. When we look at the arrow, that just means yields. Now I'll talk about these coefficients. A coefficient is a number that's written in front of a chemical formula, and it indicates the proportion of each reactant or product to one another. Notice this oxygen doesn't have a number in front of it, but technically that's a 1, so we don't write the number 1 as a coefficient. These subscripts right here and here are numbers that are written within a chemical formula, and they represent the smallest whole number ratio of each element in that formula. These lettered subscripts right here are just showing the state of matter. So if that subscript is an S, it's for a solid, an L is for a liquid, G is a gas, and if you see AQ, that means aqueous, which means it's a substance that's dissolved in water. Now next to this particular chemical equation, we see a delta H, that stands for enthalpy, and here it's telling us how much energy is given off per mole of water produced here. Basically, that's telling us that this reaction gives off heat when water is formed. If that delta H value that you see there is a negative number, we say this is an exothermic reaction and it'll feel hot. Sometimes this number is going to be positive, and if that's the case, the system is going to be taking in energy. We call that an endothermic reaction, and the reaction will actually feel cold. Now, when we balance chemical equations, what we're trying to do is we're trying to allow the system to follow the law of conservation of mass. In other words, we have to make sure that we have the same number of atoms of each element on our reactant side as we have on our product side. In your notes, there are some steps to balancing equations, so I'll work through those steps, but I think the easiest way to learn how to balance equations is to watch someone through the process. So I'll take you through the process of balancing equations for a couple of examples that you see on page 5. So the first thing I'm going to do here is I'm going to balance the silver atoms here by counting the number of silver atoms I have on my reactant and product side. Here I've just got 1 silver atom and 1 silver atom. So notice that this subscript of 3 here doesn't apply to the silver. Now what I'll do is I'll take a look at my magnesiums. I've got 1 magnesium on my reactant side and only 1 on my product side, so we say that those are balanced. Now, if I look at my NO3s, I can kind of keep that as a group. It's a polyatomic ion, and it appears as a group on both sides. Notice there's 2 nitrates on my product side, and I need 2 on my reactant side. So to fix that, I can put a coefficient of 2 in front of the silver nitrate. Now, make sure you understand that you're not ever allowed to write any subscripts after you've written your chemical equation. You can only put coefficients in the front. I've just doubled this entire compound. I now have 2 of them. So that means I have 2 silvers as well. So what I need to do is go to my product side and put a 2 in front of my AgCl so that I have 2 silvers on the product side as well. That's actually really helpful because now I've got 2 silvers and 2 chlorines. And on my reactant side, I needed 2 chlorines. So now my chlorines are balanced as well. This equation is balanced, and notice that I didn't write any coefficients in front of the MgCl2 or the MgNO3. Those coefficients are technically 1s, but we generally don't write those. As a general rule, it's a good idea to balance metals first and oxygens and hydrogens last. I'd start balancing this by noticing I have 1 sodium on the reactant side and 2 sodium atoms on my product side. I'll put a coefficient of 2 in front of the NaOH, and that'll double the sodiums. Now look at the aluminums. I've got 2 on my reactant side and only 1 on the product side. That 3 does not apply to the aluminum. I'll put a coefficient of 2 in front of the aluminum hydroxide to give me 2 aluminums. Now I've got 3 sulfite polyatomic ions. Now on this side I only have 1 sulfite polyatomic ion. I'm going to triple this sodium sulfite. What that does then is it triples my sodiums on my product side. I used to have 2, but now I have 3 times that many. There's 6, which means I have to change this 2 on my reactant side to a 6. So cross that out and make that a 6. That should do it. I've got 6 sodiums, I've got 6 OHs, and on this side I have 2 times 3, or 6 OHs. I've got 2 aluminums, 3 sulfites, and 3 sulfites. That's a balanced equation. Sometimes when I have water in a chemical equation like this, and on the product side there's an OH group and an H group separated by a plus sign, I find it easier to balance the equation by writing water as HOH. Now I'll balance this equation. So I've got a calcium ion and a calcium ion, they're balanced. On my product side I have 2 OH groups, and on my reactant side I only have 1 OH group. So I'll put a 2 in front of the water. That's also helpful because now I've got 2 hydrogens as my product side, and I've got 2 hydrogens on my reactant side. And notice that I'm just counting the hydrogen of the OH group separately. So that's a balanced equation. In this reaction, I want to show you how to use a temporary fraction as a coefficient. So here, when I look at this, I've got 2 coppers and 2 coppers. They're balanced. I've got 1 sulfur and 1 sulfur. They're balanced. When I'm trying to count the oxygens on my product side, I have 2 from the SO2 plus 1 from the copper oxide. So that's a total of 3 on this side. But I've got 2 oxygens on this side, and I really just need 3 oxygen atoms. So what I do is temporarily write a fraction. I put the number of atoms that I want, which is 3, over the number 2. Now, I've technically have 3 oxygen atoms on this side, because 3 halves times 2 is just 3. But you can't really have a fraction of a compound in existence, so I need to keep these proportions the same, but get rid of my fraction. So what I do is I multiply every coefficient by 2. So this becomes 2, this just becomes 3, this becomes 2, and this becomes 2. I wrote this twice just so you could kind of neatly write it down below. This equation is similar. You can use a fraction to balance this one. I suggest you stop this video, try to balance this, then restart it. Okay, if you're balancing this, you have 4 carbons, and I need a 4 here in front of the CO2 to get 4 carbons. Now I'll balance the hydrogens. I've got 10 hydrogens on my reactant side, 2 on my product side, so I need to multiply the water by 5. As I count up the oxygens on my product side, I've got 2 times 4, or 8, from the CO2, plus I've got 5 from the water. That gives me 13. Now that's an odd number. So what I'll do is I'll put the number of oxygen atoms I want, which is 13, over 2. So all I need to do now is take every one of these coefficients and just double them, and I'll have a balanced equation. So that 1 becomes a 2, 13 over 2 becomes 13, 4 becomes 8, and 5 becomes 10. That's a balanced equation. Now it's your turn. I'd like you to try to balance the equations on the next page, and let me know if you have any problems.